Hey, welcome back. We are in Unit 8 of AP Calculus AB, and this is our last lesson in Unit 8. I'm calling this more on the fundamental theorem of calculus and functions defined as integrals. Or maybe I should say functions defined with integrals, because they could have other stuff in it too. This is mainly just a bunch of practice problems. I really want us to just, um, you know, get used to solving a variety of problems that involve integrals in the fundamental theorem of calculus. So right off the bat, I got a practice 6.1. Why don't you give it a try? These are calculator problems, and be sure and write down the expression you evaluate, and we'll go over it. Okay, so on this question here, we need to use, let me clear out my home here. We need to use the fundamental theorem of calculus. So let's see here. We're going to say that f of 3, and I really want you to practice writing this down, is equal to f of 2 plus the integral from 2 to 3. And that is the true statement. Whatever is here, whenever I am at f of 2, I add the integral from 2 to 3 of f prime of x dx, I will get f of 3. So that is 7 plus the integral from 2 to 3 of cosine of x squared dx. What does that equal? Well, cosine of x squared, that's not something we can easily integrate, so we're going to rely on the old calculator machine here. 7 plus the integral of cosine of x squared evaluated from 2 to, evaluated for x from 2 to 3. All right, and diamond enter. And that looks like it's going to be something. Let's see, it's busy, it's thinking about it. And we get 7.241. All right. Okay, time for the next one. We have, let's see here, f of 5. What would that be? F of 5 is we're not trying to find f of 5, we're trying to find f of 4. F of 4 is equal to f of 5, which is 1.3, plus the integral from 5 to 4. And I'm okay with that being backwards, because we're moving backwards here, of e to the sine x dx. Don't forget your dx. That's very important. We want our work to be accurate. Okay. So 1.3 plus the integral of e to the sine, not second. Yes, second, sorry. E to the sine x and comma dx, comma 5, comma 4. And really check the pretty print, this thing that comes up. Make sure that it's exactly like what you like. 1.3 plus from 5 to 4 of e to the sine x dx. I like it. 0.907 is my answer. All right. Practice 6.2. Go ahead and pause the video and give this one a try now. All right, let's see about this problem. The velocity of a particle traveling on a line is defined by v of t equals 3t squared minus 4t plus 7 for t in seconds and v of t in meters per second. Find the average velocity of the particle over the time t equals 1 to 2 equals 3 using proper units, and explain the meaning of your answer. The average velocity of the particle. We need to be really careful about this. We were given v, and we want to find average v. So that's not average rate of change. That's my favorite function, the average value. So v average is equal to the integral. 1 over 3 minus 1 times the integral from 1 to 3 of v of t dt. And I don't have a lot of room to do work here. Maybe I thought this would be a calculator problem. Let's try and do it without it, though. So let's see here. When we integrate, this is going to be 1/2 times t cubed minus 2t squared plus 7t. And we're going to do that from 1 to 3. So that's 1/2 3 cubed minus 2 times 3 squared plus 7 times 3 minus another parentheses 1 cubed minus 2 times 1 plus 7. And that is going to be in meters per second because the units of the average value are the same as the units of the function. Now it wants us to find the average acceleration of the particle from t equals 1 to 3. Well, that is an average rate of change because acceleration is the rate of change of velocity. So that is going to be equal to v of 3 minus v of 1 over 3 minus 1, which is 2. So that would be 23 times 3 squared, or 27 minus 4 times 3 plus 7. Then minus let's see, we're putting in what? 1. So minus 3 minus 4 plus 7. Which is similar to what we had over here, but not exactly the same. All over 2. And the units there will be meters per second because we're dividing meters per second by 2 seconds. Okay, let's take a look at the next one. This one's a calculator problem. Give this one a try. All right, let's see how you did. The velocity of a particle is defined by f of x equals 1/5 e to the sine t. At t equals 0, the particle has a position of 3. Write an integral expression for the position of the particle at any time t. So I can do that by saying an integral expression for the position at any time t. So at t equals 0, we're going to do position. Position is s of t is equal to the position at t equals 0 plus the integral from 0 to t. And then I need to use a different variable here. So I'll say 1/5 e to the sine x dx, so that I'm using that different variable. Find the position at time t equals 5. So we'll say 3 plus the integral of 1/5 times e to the sine x dx from 0 to 5. And that is, looks like it's going to be a little while, 4.313. All right. Very good. Find the acceleration at time t equals 5. The acceleration is a derivative velocity. And I wrote f of x here. I probably meant to say v of t. That's what I probably meant to say. Sorry about that. To find the acceleration, we know that a of t is equal to v prime of t. Well, what is the derivative of v prime? That is 1/5 e to the sine t times the derivative of sine t, which is cosine t. Okay, practice 6.4. Water seeps through a filtration system. I'll let you read the rest for now. Pause the video and give it a try. Okay, let's see how you did. Water seeps through a water filtration system. The amount of purified water generated at different times t since the filtration process began is given by the differentiable function c, where t is measured in minutes and c of t is measured in ounces. C of t for selected values of t are shown in the table below. We want to approximate c prime at 2.5. Okay, so to approximate c prime at 2.5, the derivative of c at 2.5 is going to be best approximated by using values at 2 and 3. So we'll say c of 3 minus c of 2 all over 3 minus 2. So that's equal to 12.1 minus 9.4 over 3 minus 2. And the units there is going to be ounces per minute. Okay, so what is the meaning of that answer? What is this? Well, we're going to say that at t equals 2.5 minutes, the amount of water, so I start with what c is the amount of water, Now, is it increasing or decreasing? Well, it's increasing by 12.1 minus 9.4. If this was, if it was a multiple choice, you may have to get this answer, but we don't need to waste time evaluating that because it's free response. The amount of water is increasing by that many ounces per minute, and that's the meaning of that answer. Is there a time t from 1 to 3 at which c prime of t is equal to 3? Well, let's take a look at the slope of the secant line, or the average rate of change on the interval from 1 to 3. So the average rate of change from 1 to 3 would be equal to c of 3 minus c of 1 all over 3 minus 1. Well, c of 3 is 12.1, c of 1 is 6.1, and 3 minus 1 is 2. So that is going to be 6 over 2, which is 3. So because c is continuous, well, let's just say we know it's differentiable. It told us that, and therefore continuous on the interval from 1 to 3, by the mean value theorem, c prime of t equals 3 at some t 1 less than t less than 3. I'll be more strict than they said. Okay, next it says, use a midpoint sum of two intervals to estimate 1/4 of the integral from 0 to 4 of c of t dt. So we need to use two intervals and a midpoint sum. So we're going to go from 0 to 2 and from 2 to 4, but we'll be using the midpoint values. That's at 3 and 1. So I'll say that we have 1/4, that's 1/4, and then my integral will be 2 is the rectangle base, and the height, we're using the middle of it. We're going from 0 to 2, but we're using the midpoint of 0 to 2, which is 1, and that midpoint value has a c value of 6.1. Plus, again, a width of 2, and then this time a height of 12.1. And the units there is going to be in ounces, okay? Because this is the average value. This is the average amount of water the average amount of water at are over the time t equals 0 to t equals 4. It's the average amount of water that the system has generated. Okay. Next, we need to evaluate the integral from 1 to 2 of c prime of t. So we need to be careful about this. One little hint, notice that everything we've been done has been an estimate pretty much. This is not an estimate. This is saying we need to use the fundamental theorem of calculus, which tells me that this is equal to c of 2 minus c of 1. Well, c of 2 minus c of 1 is simply 9.4 minus 6.1, which is, again, in ounces. So we need to be really careful with that. That's kind of a trick question. They're asking, hey, do you know that you have everything you need to get that exact answer? All right, let's go on. Practice 6.5. And I think this is our last practice problem, so pause the video, give it your best shot, and then we'll talk about it. All right, the graph of f prime of x, the derivative of a twice differentiable function f on the interval from 0 to 6.5, is shown in the graph below. F of 6 is equal to 10. Find the x-coordinates of any relative maximums. Okay, so this is a graph of f of prime, right? So if that's the graph of f prime, then I know that f has a relative maximum at x equals 4 because f prime changes from positive to negative there. Find the absolute maximum of f on the interval from 0 to 6.5. Well, let's just use the candidates test. So first of all, what is f of 0? Well, f of 0 is going to be equal to f of 6, which is 10, plus the integral from 6 to 0 of f prime of x dx. Well, we know that f of 6 is 10, but here let's find the integral. This is 5. That's a negative, though. So this is a negative 5, positive 4, and a negative 2. But look, and a positive 2, but we're actually going backwards. So when we go backwards, this actually ends up being, this area here ends up being a positive 5. This ends up being a negative 4 and a negative 2 because we're moving backwards. So 15 minus 4 is 11, minus 2 is 9. All right, next we need to find the integral at the critical numbers. Now, I guess we should include 1. That is a critical number because f prime is 0. But clearly it's not going to be anything because it's, it doesn't change from positive to negative. But I'll go ahead and find it. F of 1 is going to be 10 minus 5, or sorry, 10 plus 5 because it's negative, but we're going backwards. So 15, and then we're going to do minus 4, so that's going to be 11. And then we definitely need to find f of 4. F of 4 is going to be 10 plus 5 is 15 minus 4. Oh, no, 15, just 15. And next we need f of, we need f of 6. That's a critical number. Oh, you know what? We were supposed to be doing, I gave you f of 6, though. F of 6 is simply 10. Okay, that's fine. But we're going all the way to f of 6.5. Let me come over and do that. F of 6.5, well, that's going to be 10 plus this area here, so that's going to be 11. So the absolute max is, and they ask what it is, so it is 15. It happens at 4, but it is 15. And we know this by the candidates test. And a little bit of the fundamental theorem, right? All right, g of x equals f of x plus x squared. Write the equation of the tangent line to g at x equals 4. So if we're going to do that, we're going to need to find g prime of 4. So let's find g prime of x. Okay, we got to be careful here. We got to use the power rule first, but we keep everything the same inside. Then we multiply by the chain, which is f prime of x, and then plus 1. So g prime of 4 is equal to 2 times f of 4 plus 4 times f prime of 4 plus 1. Well, what is f of 4? Well, we found that earlier. That's 15. So 15 plus 4 is 19 times 2 is 38. F prime of 4, what is f prime of 4? F prime of 4 is 0. Do you see that? The derivative there, because this is f prime, right? This is a graph of f prime, so that's 0 plus 1 is 1. Okay, so 38 is f prime of 4. We also are going to need to find g of 4 in order to write this equation of the tangent line. Well, that's equal to f of 4 plus 4 squared. Remember, f of 4 was 15, so we have 15 plus 4 is 19. 19 squared, you could probably just leave it as 19 squared. But it is, let's see here, 361, I believe. But I'm just going to leave it like that. So the equation of my tangent line is y minus the y coordinate equals the slope times x minus the x coordinate. That is the equation of tangent line. Part D, on what interval is f concave up and decreasing? So if f is concave up, that means f prime is increasing. That's what that means. F prime increasing. Because that's all we have is a graph of f prime, so we need in terms of that. What does it mean for f to be decreased? Well, that means that f prime is negative. So where are we negative and increasing? Over here. So on 5 to 6, because f prime of x is less than 0 and increasing on 5 to 6. And I think that's it for this lesson, and that's it for this unit. Next unit will be exciting. I can't wait to share it with you.